Let's dive right into this explainer because we've got a truly fascinating journey ahead of us today. We're going to trace a path from what was essentially a sarcastic philosophical joke made back in 1935 all the way to the very foundation of cutting-edge quantum computing in 2025. Now, you've definitely heard the name Schrödinger's cat before, right? It's literally everywhere in pop culture. But today, we're going to unpack what it actually means, why it was invented in the first place, and how it's actively shaping the technology of our future. We're starting right in the thick of it with Erwin Schrödinger's exact words from his 1935 paper. He detailed this rather morbid thought experiment that was meant to challenge the scientific establishment of his time. He basically imagined a cat, penned up in a steel chamber, with a pretty diabolical device, a Geiger counter containing a tiny bit of radioactive substance. If a single atom decays, it triggers a relay, releases a hammer, and shatters a small flask of deadly acid. But if the atom doesn't decay, nothing happens. But here is the ultimate irony of this whole setup. So often, people think Schrödinger invented this scenario to explain how cool and magical quantum mechanics is. Actually, scratch that. It was exactly the opposite. He proposed this paradox to completely mock the prevailing theories of quantum mechanics. He wanted to show his peers how utterly ridiculous a blurred model of reality would be if you scaled it up from the subatomic level to the everyday world we actually live in. Section 1. A paradox born of frustration. The clash between classical certainty and quantum statistics. So what was he so mad about? Well, the root of Schrödinger's frustration comes down to a really stark contrast. On one side, you have classical mechanics. This is the physics of Isaac Newton. It's exact, it's deterministic. Schrödinger compared it to calculating a geometric triangle. If you know one side and two adjoining angles, you can figure out the rest of the triangle with absolute razor-sharp certainty. But on the other side, we have quantum mechanics. And quantum mechanics insists on these statistical, blurry probabilities. It says that variables, like the position and momentum of a particle, simply cannot be known precisely at the exact same time. To Schrödinger, giving up that classical exactness felt like a massive step backward. To really demonstrate the absurdity of this blurry quantum reality, he outlined a very specific chain of events. Step 1 happens at the microscopic level. An atom might decay or it might not. But through the Geiger counter and the relay in steps 2 and 3, that tiny invisible uncertainty is amplified. It suddenly dictates whether a macroscopic, everyday object, our cat, lives or dies. According to quantum theory at the time, until you open the box and observe the outcome in step 4, the entire system exists in a completely indeterminate state. This is the real kicker. His absolute disdain was directed at what physicists call the psi function, or the wave function. He argued that following quantum logic, the living and dead cat would be, in his words, mixed or smeared out in equal parts inside that box. He even added, "pardon the expression," because he found the idea so logically offensive. He simply could not accept that nature operates as some smeared-out catalog of statistical expectations rather than a concrete physical reality. Moving to Section 2. The cat escapes the box, how a brief physics paragraph became a cultural phenomenon. Because the imagery of the cat in the box was so incredibly striking, sci-fi writers completely hijacked the paradox. They used it to tackle macro-level human uncertainties. For example, Ursula K. Le Guin wrote this brilliant story featuring a talking dog that results in a radical loss of certainty. Greg Bear wrote Schrödinger's Plague, where a deadly virus is in a superimposed state. It's released or contained based purely on whether a scientist is observed. And of course, literature and film everywhere heavily adopted the many worlds theory, where the cat simply survives in one branching universe and perishes in another. These stories became so beloved because of the unique challenge they present, applying subatomic logic to macro-level human interactions. Writers absolutely love taking the bizarre, counterintuitive rules of quantum superpositions and forcing them onto our everyday reality. It just leaves our minds in this dizzying state of endless possibilities, which, let's be honest, makes for fantastic storytelling. All right, on to Section 3, creating real quantum cats, from thought experiment to laboratory reality. Flash forward to today, and Schrödinger's sarcastic joke is literally a laboratory reality. A cat state is now an official, real scientific term. It describes a real-world quantum superposition of two macroscopically distinct states. So in the field of quantum optics, for example, it refers to the superposition of two opposite-phase coherent states. Imagine a large positive electric field and a large negative electric field existing simultaneously in the exact same space. No way, right? But that is a literal, physical cat state. The evolution of this concept is just astonishing. It starts out as mathematical theory with even and odd coherent states back in 1974. By 2005, a team at NIST managed to realize a highly entangled cat state using 6 distinct atoms. And then, jumping straight to February 2025, Amazon announces a groundbreaking quantum processor prototype nicknamed Ocelot, which actually utilizes cat qubits. But wait, here's the catch, and it's a big one. Creating these states is incredibly difficult because they are extremely fragile. When physicists build these states, they often work with an alpha value of 10. To put that into perspective using the language of quantum optics, that equates to a cat state made of roughly 100 photons. And this brings us to a brutal hurdle known as decoherence. In that 100-photon state we were just talking about, a tiny 1% absorption from the environment, literally just the probable loss of a single photon out of 100, ruins the superposition entirely. It completely forces the blurry quantum state to collapse. Which leads us to Section 4, building the quantum future, harnessing the cat to correct quantum errors. So, how do we overcome this fragility to actually build the computers of the future? Well, physicists solve this using something called bosonic codes. This is such a brilliant encoding method. Instead of using a simple two-dimensional system, bosonic codes leverage infinite dimensional spaces. Think like the propagating mode of an optical setup or a microwave resonator. This provides a highly efficient path to protect quantum information, specifically against those exact devastating photon losses we just mentioned. When you compare these two traditional methods, the advantage is incredibly clear. Traditional qubits rely on two-dimensional systems. If an error happens there, it's catastrophic, meaning you need massive amounts of physical hardware redundancy just to protect the data. But cat qubits, which are a type of bosonic code, encode information in distant locations of phase space using these macroscopic superpositions. By doing this, they literally bake error protection, specifically against bit flips, directly into the physical hardware itself. It's a real game changer. And the specific engineering behind it offers varying levels of defense. You basically have different types of cat codes. A two-component cat code acts as a highly efficient shield, suppressing those bit flips. But if you need even more protection, you step up to a 4-component cat code. This uses a higher dimension manifold and actively monitors the parity of the photons, allowing the system to detect and protect against complex phase flips as well. Now, what's truly mind-blowing is that these theoretical codes aren't just theory anymore. They're powering real industry shifts right now. Amazon's 2025 Ocelot chip is utilizing these very cat qubits alongside traditional tech for error correction. Plus, there's an entirely new startup architecture called Alice and Bob that's utilizing cat qubits exclusively for computing. They are proving, beyond a shadow of a doubt, that Schrödinger's 1935 nightmare is officially the bedrock of modern tech. We've seen a sarcastic, philosophical critique transform over 90 years into our actual technological future. As these cat qubits power the next generation of computing, it really leaves us to ponder, when exactly does a quantum possibility become a physical reality? It's a question that started as a joke, but today, the answer is actively being built in the lab. Thanks for joining me on this explainer. I hope this helped clear up the incredible science behind the famous cat.